we'll be talking about the human eye and how our brain can get information from out there into here. So to start with, let's look at a model of the human eye. So here's a model of our eye. And the parts that I'm interested in are really the inside. So what I'm going to do, I'm going to take off this front part, and let's take a look at what we've got here. So in the eye, we've got the lens, and you can see it is thicker in the middle, so it's a converging lens. And light from outside is going to go through the lens and then be sent to the back of the eye, which is our screen, our retina. And so light comes in, goes through the lens, and forms an image on the retina. And that's the basic, that's the basics of how light passes through at a very, very minimalist model. And then the light that hits the retina all that information gets sent to the optic nerve, and from the optic nerve gets sent to the brain. So that's the basics. Let's see how the light actually behaves. If we have a basic human eye, and this model isn't perfect, but the model does work. And we think about light coming into the eye. Let's see what happens. So I've got light rays coming in, and we need a little bit more light than that. How about this one? There we go. And so the light rays that come in, if we have a normal working eye, those light rays meet up and are focused very nicely down at the retina on the back of the eye. So that is a normal working eye. But many of us have vision correction. So what is going on with that? Well, let's start with a nearsighted eye. Okay, so a nearsighted eye is an eye that's actually longer than normal. And this model here isn't perfect because this stays the same. I can't, change this. So we're going to change the lens a little bit. But really, a nearsighted person like me has an eye that is longer than normal. So if the eye is longer than normal, predict where those light rays are going to come in and get focused down. So if the eyeball's stretched a little bit, where do you think those 5 rays are going to be focused? Okay, got your prediction? Let's give it a try. So for a nearsighted person, a longer eye means that those light rays get focused down in front of the retina. So instead of being focused on the retina and we get nice crisp vision, we have them focused here, and by the time the light actually gets to the retina, it's spread out, blurry. So what kind of corrective lens would we want if we are going to fix a nearsighted person's eye? Think about the 2 types of lenses we have. We've got converging lenses and diverging lenses. Which one would you want in order to fix these rays so that instead of coming to focus here, they come to focus back here on the retina? So think about it for a minute, make a prediction. What kind of lens would we want to put in front of a nearsighted person's eye? Okay, make your prediction. Let's give it a try. If we want to move these light rays farther out, we want them to be spread out a little bit more. We don't want them to meet up here. We want them to meet out back here. We need them to spread out a little bit more. Spreading out, diverging, we're going to use a lens that is skinny in the middle. And when we put a diverging lens, it's not perfect, but hey, when we put a diverging lens in front of the eye, then those light rays, again, take a look, they get spread out. So watch kind of the spread when I put the lens in. They definitely get spread out more. So they spread out more, and then we get a nice, clear, crisp image that is focused on the retina where we want it to be. So that's a nearsighted person. A nearsighted person has a longer than normal eyeball, and so the light is focused in front of the retina. We need a diverging lens to spread those rays out a little bit so they meet on the retina. You can probably guess what's next. A farsighted person. See if you can predict while I'm setting this up. Okay, so a farsighted person, you can probably guess, has an eyeball that is shorter than normal. So if the eyeball is shorter than normal, where are the light rays going to meet up? Instead of meeting up on the retina, now we squish the eyeball together so those light rays are meeting up behind the retina. Oof, we're somewhere back here. And so now the light rays meet up behind the retina. The retina, instead of seeing a nice sharp image, sees this blurred out image. What kind of lens are we going to use to correct this vision? Well, now we want these light rays to meet up earlier, more this way. And so we want to squish those light rays down so that they meet up on the retina, which means a converging lens that converges light. So let's give it a try. If we've got our farsighted person, the light is meeting up at behind the retina. We put a converging lens in, and now we've got our light meeting at the retina. Yep, and so now that corrective lens means the light's meeting up here, and there we go. And we see a nice crisp image. So that's the basics of human eye vision. Now there are a couple other fun things we can do. We can find your blind spot. Now what's a blind spot? Well, let's turn on the lights again. So every eye has a blind spot. This is a place where the retina is not collecting information. Can you see why there would be a place where the retina is not collecting information? Well, there's this point right here where the optic nerve is connected. And so that point, let's see if I can get this out. So here's my retina. And so light's coming in through the lens and being shown onto the retina. And then all that information from the retina is being collected and popped into the optic nerve. Optic nerve connects to the brain. Okay, so what is a blind spot? A blind spot is a spot where there's no data being collected from the retina. You are not collecting information visual information from the world around you. Where would that be? Well, I think it might be right there. So the place where the optic nerve is connected is a place where there's no screen, effectively. There is nothing gathering information there. This is the point where all the information gets passed along. So every eyeball has this blind spot, and you can find your blind spot in a couple different ways.